Welcome students, in this video we are going to talk about non-homogeneous system of OD. So essentially we have a problem like this: x prime of t equals to a of xt plus small b of t. Okay, here of course given that this is our assumption, a is a constant matrix of size n cross n. Okay, of size n cross n. Okay, I'm not writing all that. So yes, and B is a column. B is a column vector. Okay, depending on t. So basically, what I'm trying to say is, please don't get confused here. That depends. B depends on t. Yes, it varies with t. Okay, it may be constant, but it varies with t. Generally speaking. Okay, so let's just call that 1. Correct. Now, but again, one thing I want to emphasize here: A is a constant matrix. This is very important thing. Okay, you cannot use whatever I am doing will not work if A is a variable coefficient. So basically, A depends on t. You can't do this thing here. Of course, I am looking for 1. So what is our aim? Is to find the solution of 1, okay, and provided, so basically we are looking at a solution of 1 provided x at the point t naught, or let's just do 0. X at the point 0 is given by x naught. Clear? So that is also a vector. This is a column vector, or column, whatever you want to call it, column matrix, column vector, whatever. Yes. So essentially this is the problem given to us, and I am saying that x at the point 0 is given by x naught. Okay, I want to find out the general solution for this problem. Now of course we know that you see, if it is given that x naught equals to x0, then we are basically looking at a particular solution for this problem. Okay, right. Now how to get that solution, let's just look at it. Okay, so essentially let's just I think you guys know from that ordinary differential equation, there is something called the principle of variation of parameter. Okay, we are going to do exactly the same kind of thing, variation of parameter. So in this case it's called the Duhamel's principle. Okay, this thing, why I want you to understand this thing properly is this, the importance of this. Okay, so let me just put it like this: importance of 1. Okay, why is 1 so important? Okay, so 1 is important because you see, you can use the technique which I am going to do here. The technique is very efficient to deal with PDEs also. Okay, with evolution PDEs, evolution partial differential equations. Okay, so that is to say that if you want to work with a inhomogeneous wave or heat equation, okay, then you can use Duhamel's principle to do so. Do you understand? So what is the Duhamel's principle? It first says is what it says is this. So first of all, look at this problem. Look at the corresponding homogeneous problem. So look at this problem: x prime t equals to a of xt. Let's just call it 2. Clear? Now this problem, if we, of course, how many linearly independent solutions are there? There are n, right? For given A is n cross n matrix, so there are n linearly independent solutions. Let's just call that as the linearly independent Li solutions of 2 are given by x of 1 t, x of 2 t, and x of n t. Clear? So there are n linearly independent solutions. Okay, and the general solution, how do you write the general solution? Okay, let's just call it as x. Okay, let's just call it as y xg of t. Okay, so that how can you write it? You can write it as c1 times x1 of t plus cn times xn of t. Clear? The general solution can be written like this. Okay, now if you want, you can also write this Yes, so you see this, okay, so this let's just call it 3. Okay, so the general solution of a homogeneous problem is given like this. Yes, what do you want to do? So if you want to write it, you can write it like this. It is in terms of phi of t, where phi is the fundamental matrix times the constant matrix C, right? So phi is the fundamental matrix. You can write it like this also, okay? And C is any arbitrary constant. So C is basically a vector, a column vector which is given by C1, C2, Cn, okay? So C is given like this, capital C, okay? So x of g can be written like this. Now what we want to do is this, see, essentially, so C is a n cross 1 vector, correct? It's an n cross 1 vector, okay. Now you see, what we are going to do is we are going to vary the parameter. So basically we are going to vary C. Here now we are assuming, so let us just assume that, you know, x of t, which is the solution, solves 1, and x of t looks like this. X of t looks like, okay, see, I am saying that there is a solution of 1 which looks like, so since homogeneous problem looks like this, we are just varying C, and now I am assuming C does not only is a constant but also depends on t. So basically x of t is phi of t times C of t. Clear? Okay, this is what we are assuming. Now if that is the case, then let's just say, let's just look at what is x prime of t. If I just do x prime of t, it is phi prime of t times C of t plus phi of t C prime of t, okay? I am just taking the derivative, normal Leibniz rule and everything works, so you don't have to worry about all of this, okay? Now see, what is x prime of t? It is a of xt plus b of t, right? And that is equals to phi prime of c t times C of t plus phi of t times C prime of t. Clear? Of course, here C of t is a vector valued function. This is an n cross 1 vector valued function. So basically what I am trying to say is C of t. So C, it is from I to Rn. Clear? So basically for every t it is giving you a n double essentially. Okay. Now x prime satisfies this problem. Okay, so x prime is given by this, and again phi prime. What does phi does? You see, phi is a fundamental solution, right? So phi satisfies 2. Clear? Okay, so phi satisfies 2. So basically I can plus b of t. Phi satisfies 2. So phi prime of t is a of phi t, correct? Times C of t plus phi of t. Okay, now what is x of t? X of t is given by phi of t, C of t. So a phi of t, C of t plus b of t equals to a phi of t, C of t plus phi of t, C prime of t. Okay. Now, so what does that gives you? So these and these two are essentially the same thing. So essentially what I have is C prime of t, okay, times phi of t is given by b of t. Okay, so the fundamental matrix phi of t times C prime of t is given by b of t. Okay, now what is C prime of t? So basically this is phi inverse of t. Since phi is a fundamental matrix, the inverse exists for every t, right? So I can take the inverse here. Yeah, phi inverse of s, b of s, ts. Is this clear? Okay, now you see, therefore, hence, what is x of t? X of t is given by phi of t times C of t, right? See, phi of t times C of t. So I will just put the value of t. So now I just multiply phi of t here. Okay, now don't change the orders. You do understand these are all matrices, so the order has to be taken care of when you are writing it, right? Okay, so if I multiply both sides with phi of t, I get x of t equals to phi of t, phi inverse of 0 x naught plus phi of t, okay, fundamental matrix at t 0 to t, phi inverse of s, b of s ds. Clear? Okay, so I mean, this is what we are getting. So this is the solution. I mean, that's done. Now you see, of course, if you have a fundamental matrix, you can write it like this. Now, do we have a fundamental matrix? Do you think we have a fundamental matrix? Okay, of course we do. Okay, see, essentially, we can assume that x of t, if so, e power at is a fundamental matrix. I hope this is fine. We talked about it in the last discussion class. Okay, so fundamental matrix, sorry, it's a fundamental matrix solution. Okay, yes, so xt can be sorry, not xt, phi of t, sorry, phi of t can be assumed to be e power at. Okay, that's a fundamental matrix. So if I just replace it, what do we have? Therefore, any solution x of t, it will look like exponential at exponential 0, which is identity. So basically this is exponential at times x naught. Okay, so this is basically the the solution corresponding to the homogeneous problem. Plus, so here the inhomogeneous part is coming 0 to t. Phi of t is exponential at. Phi inverse of s is exponential minus as. Yeah, that is fine. So essentially this is in exponential a t minus s. Okay, and you have b of s ts. Clear? Okay, clear? So and that's your solution essentially. Okay, so basically, I mean, in terms of exponential, if you want to write it, that's your solution. Okay, so any solution x of, so not any solution, the solution of xt. Okay, the solution of 1 is the solution of 1, that solution of 1, okay, that is given by exponential at times x naught plus 0 to t exponential a t minus s bs ts. Yes, I hope that is clear. So that is the solution. Now let me do one problem, and that then that will be more clear actually. Okay, so x prime t is, and I'm not going to write down every detail of it. Okay, I want you guys to please verify this thing. 1 minus 2 and 3 2 1 x plus 0 0 e power t cosine 2t. Okay, of course you are given x at the point 0 is 0 1 1. Okay, so essentially this is the problem which we have. This is the inhomogeneous problem because of this term, right? That's our b of t. Now let's just find out the solution. What you need to do? First of all, you need to find what e power at is. So homogeneous problem. Okay, so right, what is a? A is given to be this, right? 1 0 0 2 1 minus 2 and 3 2 1. Okay, so the eigenvalues values are given by 1, okay, 1 plus 2i. Clear? Okay, we did this I think earlier. Okay, so that's the eigenvalue and the eigenfunction. So what is x1 of t, which you are going to get, is e power t times 2 minus 3 2. Okay, x2 of t corresponding to complex eigenvalues. I told you that you can actually break the real and the imaginary part in the two different way, and you get two different solutions out of it. So basically two linearly independent solutions. E power t, so this I'm just writing it down. Please verify this thing. Yeah, see, once you verify one problem, you actually can do most of the problems here, which is of this form. So I mean, you just have to verify this one. So 0 sine 2t and minus cosine 2t. I hope this is fine. What am I doing? First of all, I have the problem A. See, homogeneous, inhomogeneous, whatever you have, don't worry about it. First of all, start with A, find the eigenvalues and the eigenvectors. So the first eigenvector corresponding to 1 is this. The second vector corresponding to 1 plus 2i is, of course, this one and this one. So 1 plus 2i, this is a double this thing. What do I say? the double root. Okay, so 1 plus 2i, 1 minus 2i, that is there, plus minus. Okay, but I mean, you do realize that if you are taking minus, you will get the same sort of thing with some extra constants. Okay, so I am not really worried about it. Correct. Now I have all of this. Now you see, I need to find the solution, this solution. Yeah, I need to find the solution for this problem. So let's just call this problem as 3. I need to find the solution of 3. So my b of is given by b of e of t cosine at. Okay, so how do I find it? So first thing first, what is the fundamental matrix phi of t? Let's just write down phi of t. It is 2 e power t. Okay, 0 0, okay, minus 3 e power t cosine 2t and e power t sine 2t. I hope you understand what I'm doing. I'm just writing the components like in a column. That is what what did I teach you? You see, whenever you want to write a fundamental matrix phi of t, how do you write it? You just write x1, x2, x3 in the columns. Okay, so the third is 2 e power t and it is e power t sine 2t and it is e power t cosine 2t, right? That's your fundamental matrix. Yeah, and I mean, here also I'm not doing this thing, but see, these are tedious work, but the thing is, it's not a extremely difficult thing to do. You understand? Okay, so the inverse you have to find the corresponding to t equals to 0. So 1 0, again I am writing this one. Okay, there is nothing special going on here. Okay, okay, now you see here what is happening is this. First thing first, I have to find, you see, e power at times phi x naught. Okay, so x of t looks like this, e power at times x naught plus this integral also we have to calculate. Okay, so before doing that, what we do is, first of all, let's just calculate e power at. E power at here is this. See, e power at is x of t phi inverse of 0, right? So let's just calculate. Therefore phi of t phi inverse of 0, that is e power at. Yeah, now how do I calculate this thing? I mean, of course, I am going to write it down. Yeah, and you are going to verify this thing. It is 1 0 0. Okay, and it's a big one, minus 3 by 2 plus 3 by 2 cosine 2t plus sine 2t and 1 plus 3 by 2 sine 2t minus cosine 2t. Okay, and sine 2t cosine 2t and minus sine 2t and cosine 2t. Clear? Okay, so I mean, I just multiplied those two. So basically e power phi of t phi inverse of 0 is e power at. I mean, you can do it like this, or you can okay, you can just calculate what e power at is. For given a, you can see that if you can directly calculate e power at, then also that's fine. Huh? Whatever you want to do it, you just do. But this is just one way of doing it. Yes. Okay, now that is the first case. Yeah, this is the first part we just got. I mean, now you have to again multiply it by phi 0. That's there, x naught. That's not the problem. Huh? So now you see, now e power at, yes, times x naught. So x naught is given as is 0 0 0 1 0 times 0 1 1. Okay, so this part, yeah, this part is given by e power t 0 cosine 2t minus sine 2t. Okay, I'm just multiplying this thing with 0 1 1, that's all. Okay, and cosine 2t plus sine 2t. Okay, so that's the first part, this part. Yes, now I have to calculate the integral part also, and then you have to add all of those up. So see, the one major important thing is I want you to show how to calculate this integral part. Okay, so first thing first, e power at, yes, times 0 2t e power minus s. Okay, see here, e power a t minus s b of s ds. I need to calculate this whole thing. Okay, I need to calculate this whole thing. So that is what I am doing. Where is it? So now I have e power as. You see, e power as is this. So this e power t is getting converted to s because I am just writing this integral. You see, this integral is e power at. I am taking it outside. E power minus as bs ds. E power minus as is this thing. E power minus a s. I have to write this thing in terms of s. Okay, so that is what I am writing here. 1 0 0, okay, times 0 0 e power s cosine 2s ds. Okay, and here again I am just writing whatever we just did, but in terms of s here, cosine 2s minus sine 2s, and this is cosine 2s, this is sine 2s, and this is 1 minus 3 by 2 sine 2s minus cosine 2s minus sine 2s and cosine 2s. Clear? Okay, this is just that part. I just wrote it in terms of, so this is e power minus as part. Okay, fine. Now what is it? This is e power at times 0 to t. If you multiply this with this, see, essentially I am just left out with the column matrix, right? This is a 3 cross 3 matrix, this is a 3 cross 1 matrix with the first two row 0 0. So essentially I have only this part to worry about. So I have 0. So if I just calculate everything together, it will become sine 2s cosine 2s and cosine square 2s ds. Clear? Okay, just putting everything together, I will get this thing. Okay, now if you get something like this, that is going to be e power at. Now what is this integral say? See, whenever you are doing an integral for column vector, it means that you are doing integral for each of the terms. Okay, so here it means that integral of 0 is 0, integral of sine 2s cosine 2s, that will be half sine 4s. So basically it is 1 minus cosine 4s by 8. Okay, and this one is t by 2 40, sorry, 40, because of 0 to t I am calculating. Okay, t by 2 plus sine of 40 by 8. Yeah, I hope this is clear. What am I doing? I am just integrating every term one by one. Okay, so this is integral is 0, this is half sine 4s, which when you calculate, it is 1 minus cosine 4s by 8 when you calculate between 0 and t. Okay, and similarly this term when you calculate, it is you can write it as half 2 cosine square 2s, which is in terms of sine 4s cosine 4s. So basically when you calculate between 0 and t, it is t by 2 plus sine 4s. Okay, so I think this is fine. Now when the general solution, therefore not the general solution, the solution x of t is essentially this particular thing plus this one. Okay, so let us write it down. It is e power t. Okay, if I just write everything together, e power t. Okay, and then it is 0 cosine 2t minus yes, this is fine. You have to do more work also. See, e power at is this thing, right? So now this thing you have to multiply it with this. Okay, so you will get another matrix. Okay, and then you have to add it with this particular term. Okay, so to be very frank, it's a very big calculation. Okay, but I mean, it's not difficult, but it's big. That's the problem. 1 plus t by 2 sine 2t and 1 plus t by 2 cosine 2t plus 5 by 4 sine 2t. Okay, So this is how you solve a inhomogeneous problem. I hope this is fine. Okay, I did not do these calculations. Please do it, check it yourself, verify once, and then I think you will be quite clear of what is going on. Okay, so with this we are going to end this video.